Today we continue discussing circles. Yesterday we used a lot of definitions, diameter, chord, tangent, uh, secant, radius, and diameter. And on our first day of talking about circles, we talked about area, or circumference and area. Now we're going to go dig in a little bit deeper on circumference today. So if you understood Monday's assignment, this should be relatively simple. So as we said, circumference is the distance, the perimeter around a circle. Okay, they've got the diameter marked here, D. Remember, the diameter is the chord that goes through the center of the circle. Okay, so it's the full width of the circle, if you'd like to think of it that way. And then half that width is your radius. So circumference is pi times diameter. Remember, pi is equal to approximately 3.14. In general, that is as many digits as you need. Here, the number pi is on my calculator. I'm going to try and highlight it right there. If you're looking at the video, that's the pi button. And you can see pi is equal to this really long decimal. In fact, this decimal goes on and on forever. It never repeats itself. It's a type of irrational number is what we call it. And so we have to use this symbol, pi, and the pi symbol is just two legs with a little curvy lid on it. That represents all of those digits. And in fact, pi is defined as the circumference divided by the diameter of any circle. If you took any circle and found that ratio, it would always come out to this 3.14 or pi. So now that we know what pi is, so circumference is pi times diameter, or 2 pi r. So just a couple of quick examples here. Find the circumference of a circle with a diameter of 5 inches. So number one, here's what we're trying to do. Find circumference given, let's see, diameter 5 inches. So to find circumference, we can use pi times d. So 3.14 times your diameter, 5. And we'll just grab our calculator, get our answer here. 3.14 times 5 equals, so a circle with a 5-inch diameter would be 15.7 inches all the way around it. Problem 2, find the diameter. So diameter equals what? That's our question mark. And they tell us circumference is 17 feet. So I'm going to have to work this a little bit different order. Circumference equals pi d. Let's solve this for diameter. Oops, not divide by d, we'll divide by pi to get diameter alone. And so d equals pi over pi is just 1, and d is equal to circumference over pi. So for us, circumference is 17 feet, and pi is 3.14. So 17 divided by 3.14. Diameter of about 5.41 feet. So that's just a quick review of circumference. Today we're going to expand on that. We're going to find the arc length. So let's take a look at first what we mean by arc length. The arc length is just a portion of the circumference. Remember, circumference is distance around the circle. And if we want an arc length, we want a portion of it, and that's this red highlighted part. So I would like to find just that length of this distance around the circle. Okay, so that is our arc length right there. and it's pretty easy to calculate. You can see here in our core concept, the ratio of the length of a given arc to the circumference is equal to the ratio of the measure of the arc to 360 degrees. So let's make sure first we understand where we're talking about measure of arc. So this is our arc length in red. Let's put it in red. And this angle in here is the measure of the arc, or the arc measure. Okay, and so that's going to be in some degrees. So that is the angle. So here's what we're basically saying in this problem. Then we'll look at the formula. We're saying the ratio of this arc length to the whole circle is going to be the same as the ratio of this arc measure to 360 degrees, which is the measure of a circle. So we're doing angle to the whole is equal to arc length to the whole. And so when we do it to the circumference, because we're going to do this little section over the whole thing, that's just circumference, or 2 pi r. So you can see how we've got it set up here. The ratio, the arc length, that's the AB that's highlighted in red, over the whole distance around the circle has to be equal to the little angle that's marked out over the whole angle, or the sum of all the angle in the circle. They've taken it one more step here and just multiplied both sides by 2 pi r. What that does is lets it solve for arc length of AB is that ratio of the angles times circumference. So let's take a look at this in action. Find AB. So I do think it's easiest to set it up like a ratio. So we're just going to go arc measure over 360 equals arc length over 2 pi r. And arc measure is 60. Remember, that's the angle over 360. That's equal to the arc length. See here, that's AB. I gotta make sure I get my notation right. And there's right arc length. Boy, I wish they had a nicer notation for that. Oops. And that's what we're looking for, all over 2 times pi times our radius, and our radius is just 8. So there's our setup for it. Now, in practicality, then, what you want to do is just figure out what this ratio is equal to. You can use your calculator for that. And then you just have to multiply both sides by this 2 pi 8. The circumference of the circle. So let's look at how we can do this in our calculator and make it super efficient for us. Let's pull this up. And we'll zoom in here. So first I'm going to calculate what 60 divided by 360 is. And these decimal values, now we're not super pleased with that 1.6 repeating, but because we're only taking pi out to the hundredth spot, pi only has 3 digits in it. We'll just make sure we keep 3 in this. So we'll go 0.167 equals arc length AB over, and let's find out what 2 times pi times 8 is. And we get 50.24. And now we just have to multiply by 50.24 on both sides. On the right side, it will cancel. And on the left side, we will finally have our answer. So I'm going to clear that out. I'll type in my 0.167 times 50.24. That little piece of the arc is 8.39. And I don't know if they gave us any units. Centimeters. They did. The radius was in centimeters. So this little arc length is 8.39. Now, I think a better way, and maybe this, because this is how my head works. I go, all right, the arc length I'm trying to find is 60/360ths of the circle. Well, 0 over 0, 10 divided by 10, top and bottom, 6 over 36 simplifies to 1/6. So I have 1/6 of the circle right there. And then what I do is I say, well, what's the circumference of the circle? Well, circumference is 2 pi r. And that's what I calculated to be 50.24. So the whole circle is 50.24. I've got 1/6 of it for my arc length. So if I want the measure of arc length AB, all I think of in my head is I need 1/6 of the 50.24. And so I go 50.24, and I'll just divide by 6. And I get 8.37. And so you can see, because of our rounding, we were off by just a little bit. So I don't even generally think of this equation when I try to solve these problems. Let's look at the next one. All right, find the indicated measure circumference of circle Z. Okay, so we're looking for the whole thing. So in this case, they've given us this little arc length right here is 4.19. So we know it marks off 40 degrees of the triangle, so that's 40 degrees out of 360. Again, divide by 2, you get 4 over 36. So that's 1/9 of the circle. So 1/9 of the circle is 4.19. I just don't know how big the circle is, but I know this now. 1/9 of the circumference, the whole thing, should give me this arc length right here, 4.19, because that's 1/9 of the distance around it. And now I can just solve that. Take it times 9. And I get C equals, and I should use parentheses there so you could see it better. 4.19 times 9. 37.71, and we're in inches. And our last one. Let's see, find the measure of RS. And notice how this is marked. That means this angle right here. Okay, so that's only part of it. So I'm trying to find measure of RS. So that'd be like, I don't know, it's short of 180 degrees, so about 160 degrees, somewhere in that neighborhood. But that's, 160 degrees out of how much? 360. And that should give you the same as the ratio of the arc length that's figured out. So arc length of SR, or RS, divided by the whole circumference of the circle, and that's just 2 pi r. So we are looking for this guy right here. So measure RS over 360 equals 44 meters over 2 times pi times our radius. And the radius they gave us is 15.28. Well, let's go ahead and let's crank this right-hand side here. Let's go ahead and knock him down to a decimal. I think for this, I'd probably calculate my denominator first, and then I'd do 44 divided by that denominator. So I just switched to money somehow. Here we go. So 2 times 3.14 times 15.28 equals. So that is now 44 over 95 point, we'll call it 96. Then I'll do that division on the right hand side. So 44 divided by my 95.96. We'll call it 0.46 equals m over, or measure RS, 360. And so I got to take that 0.46 and multiply both sides by 360. And I'll finally have the measure of that angle RS. So 360 times 0.46. It is 100, I guessed about 170, 165.6, and that is an angle measure right there. So it's about 165.6 degrees. And that is it. I'm trying to think if there's an easier conceptual way to think about what I just did there, rather than just powering through the formula. And so essentially, here's what went on in that problem. I knew that this arc length, or the measure of this arc, was 44. So that's 44 out of the whole thing, the whole circle. And so I would just go ahead and calculate that real quick. 2 times the 3.14 over that radius. So I'm getting that ratio of arc length to the whole thing. Now when I do that on my calculator, I'd probably do it this way. 44 divided by. We can divide these things out separately. So I would go divide by 2, get an answer. Then I'd divide out the pi, 3.14, get an answer. Then I'd divide out the 15.28. I don't think I typed in 15.28. So I'm going to do that again real quick. And maybe that's what I had. Regardless, that should be right now, 0.46. So I have 0.46 of the circle, essentially. Well, a whole circle is 360 degrees, so I just need 0.46 of the 360 degrees. So times 360, and there's that 165.1 degrees. So we get to the same answer. That's just a different way to think about it.